So in the last classes, we have discussed about the network function virtualization. So network function virtualization is basically uh, virtualizing the network functions used in network in the networks. So network functions include functions such as routing data, and managing the load in the network. Managing that means managing the data traffic in the network, then securing the network from unauthorized access, and then fault tolerance, which means that if there's some kind of a link that is not functioning properly between two devices in a network, then how to avoid such kind of broken links, and how to forward the data in the most reliable manner through a reliable link. So those network functions can be virtualized using software programs. So we can write software, scripts and install them in servers, which can act as the network component, which is doing the network function. So earlier in the traditional networks, we had separate specific hardware for conducting specific network functions. However, now we can buy a server or a computer and install the virtual machines in the computers, and then we can install the network functions in those virtual machines. And by doing so, we can convert that server um, into a network component or a network device that can do multiple network functions. So not only one network function, but we can have 2 or 3 network functions installed in a certain network device. So this increases the flexibility of network functions in the network, and increases the like PCB, I mean practical implementation of the network functions, um, such that we can easily implement those functions in servers in the way we want. We can, I think we discussed about this. We can even install, and we can move the network functions from one location to another location, from one server location to another server location. So all those things can be controlled. So the controlling part of all those, data communication and controlling uh, of the data traffic, and the functioning at network devices can be done using the SDN technology. So we can control the functions or the activities or operations done at each network device in the network using SDN technology or software defined networking. So that is how this network function virtualization gets connected with the SDN. So network function virtualization is about uh, using network functions uh, which are made into like software programs, and installing them in certain uh, specific servers. So once you have installed them, now the time has come for us to use those network functions to do the data communication in the optimal manner. For that communication to happen between servers, a certain central controller is used. So that technology, where we use a certain centralized controller to control the network functions, and forward the data optimally from one server to another server, is known as the SDN technology. And SDN controller is responsible for controlling the data communication, and controlling the data communication between devices in the network mainly. Apart from that, the SDN controller can also configure each of the servers or each of the network devices. It can configure these devices. So because of that, SDN is able to actually uh, control the operations at the server level as well, which also helps to increase the efficiency of the network in cases where we want to control the network functions at each device level. So software defined networking is what we discussed in the morning class, and I believe that I mentioned the main concepts there. So I would like to repeat those concepts as a summary. So in traditional networks, we have this kind of a network where we have uh, switches, routers, um, hubs, and other kind of network components connected to each other. So when we take these devices, they will have a control plane to transmit control messages and data plane to transmit data messages. So once you have those control planes and data planes at each device level, then the device has to do both those operations at the device level. So this can actually be a problem when the network becomes large, when the number of components in the network becomes large. So in that case, once the network size becomes large, then we can use as a solution a centralized controller to control the network traffic in the network. Um, uh, so the SDN controller has the overall knowledge about all the network devices that it is connected to. So each of the devices will be uh, connected to the SDN controller. So in the SDN controller based technology or SDN technology, the devices do not have any idea about the overall network. The SDN controller will give them commands on how to uh, operate. So the controlling commands will be given by the SDN controller. The individual devices do not have to think about um, what they need to do with regard to data forwarding. So all those instructions will be provided to them by the SDN controller, which is the centralized controller. So the SDN architecture consists of three main components. So SDN architecture has the controller, basically the controller, which is given in here. The controller is situated in the control layer, and it will be the basic network operating system. Then the controller will be uh, connected to network applications through a northbound open API or a northbound interface. So this I will explain in a little while. So the controller will also be connected to each of the devices using the southbound interface. So we discussed about controller being connected to the routers, switches, and hubs, or any kind of network components. So the controller will be connected to each of those network devices, routers, switches, those kind of network devices through the southbound interface, southbound open API. So there are different protocols that are used by the controller to communicate with these network devices. So those kind of protocols are open flow, and then there are configuration protocols. So specific protocols are used to do the communication between the controller and the network devices. So the interface that is used for the communication is known as the southbound interface or southbound API. This southbound API or southbound open API, we can call that. That API is used to create the communication link between the controller and the network devices. Then the controller also connects to the network applications, right? So network applications through the northbound interface. So what we mean by this network application is that the customers who are using this network can access the network services that uh, that the network provides um, through these network applications. If a customer wants to transmit some video files, let's say, through a certain optimal path or in a certain manner, with low latency and with high reliability, for example, then that customer will say the customer wants to send the video files in a certain path, the network, uh, and that communication needs to be done with a certain delay or some kind of reliability. The customer can give some requirements that they have. So those kind of requests will be forwarded to the network application by the customer. Once the network application has those requests, the network application will forward such kind of requests to the controller using the northbound interface protocols. There are certain protocols that are used in the northbound interface. Those kind of protocols include protocols related to the RESTful API. Okay, so the REST APIs or RESTful APIs we call are representational state transfer protocols, and those protocols can be used in here in the northbound interface. So HTTP is one of the RESTful APIs, and so HTTP protocol can be used by the applications to access the SDN controller. So HTTP protocol, as you know, uses certain request methods. So it uses get, put, post, delete, such kind of request methods to access the network, access the controller. So, so such kind of request messages can be sent to the controller, and such kind of request methods will be formed in a certain standard format. So only then we will be able to obtain resources from the network controller. Or else if we want to update any resources in the network controller, we can do that by sending the messages in a certain standard format. So when we talk about the protocols that are used in the southbound interface, specifically in the southbound interface, these are the protocols that are used. The network traffic control protocol, or the protocol that is used to control the traffic in the network, is known as the open flow protocol. And then we have the network device configuration protocols also. So these configuration protocols are protocols which are very static. So these protocols cannot be modified by customers or any other users. So these are protocols that are defined and cannot be changed once they are installed in the once they are installed in a certain device, and these protocols cannot be, cannot be modified by a third uh, a person who's accessing the network. However, when you consider the open flow protocol, it is a protocol that can be adjusted by a person who's accessing the network or a person who's managing the network. So SDN controller is used by organizations that want to control their network. So the organizations can update the open flow protocol in a way they want, such that they can control the data traffic in a certain specific manner. However, these network device configuration protocols cannot be changed even by the organization. Once they use these protocols, they will be used basically for configuration purposes, and the standard steps followed in that configuration, and the procedure will be static. So therefore, these protocols such as simple network management protocol or SNMP and the netconf protocol or network configuration protocols will be static protocols. The open flow protocol, however, is an open source protocol, and therefore it is a protocol that can be accessed by um, you know a third party, and then these protocols can be modified according to their needs. So the source code is openly available to anyone to modify. SDN architecture can be used for IoT applications as well. So that is the main reason that we discussed about the SDN technology, this module. So IoT, as you know, like adds a lot of data traffic to the internet. So in most cases where IoT network is used to cater massive amounts of customers or massive amounts of IoT devices, um, then we are adding a lot of data traffic or data into the network. Ultimately, those data will be uploaded into the internet, right? So therefore, whatever uh, whatever we do, most of the time, the amount of data that we are uploading to the internet will be kind of congesting the network. Because of this, the use of SDN controller is a like important um, addition to the network to control the data congestion that can happen. Data can get congested in the network, and the data can be lost in the network if the data is not properly sent from the source to the destination. Uh, then the data can be lost, and then data can be congested in the network. So those things can reduce the reliability of the data communication, such that the data can be lost and then you will lose the data. So the reliability of the communication will be lost, and then also the delay of the communication will increase if there's congestion in the network. Um, so it's vitally important that we update the data on time. So in this situation, there are some certain IoT devices and sensors uploading data to a certain edge server. So the data will be traveling through these routers and switches and like reaching this cloud server, and the cloud server will store the data that is uploaded from the IoT network. So if the cloud server does not obtain the data on time, then the data will not be stored on time on the databases, and these databases will be accessed by certain cloud applications, and the cloud applications will be accessed by certain customers, and the customers will not be able to get updated data on time if the data is getting congested in an intermediate location in the internet. So because of all these things, we need to ensure that we dynamically adapt the networking functions using maybe SDN technology to increase the efficiency of the communication and reduce the latency of the data transmission, and also increase the reliability of the data that we transfer. And we need to ensure those things. So we need to make sure that we don't lose a lot of information. So it's really important that we maintain the data communication reliably in the communication system. Okay. So do you have any questions up to this point? You can speak up if you have any questions, no problem.
No.
Moreover, I will give. Okay, so thank you. Okay, Gunawardhan, I think. So I think I will give a small quiz for you to do about SDN and NFV. Once you complete that, we will start the next session. Um, in the meantime, I think that I have given like 6 assignments for you to do. So I will discuss about the assignments also. Right. So I hope you can see the screen. So I will give this quiz and another quiz in today's class because you came somehow to the lecture. Okay, so I will be adding the quiz marks as a bonus point to your final grade. Also, in the final exam, I'm hoping to give MCQ questions. So that is the main reason I think these quiz sessions are also important because sometimes some of the questions that we discuss uh, can also be possible questions in the exams. So you will have about nearly about I think 30 questions of MCQ in the end exam. If you have any questions related to those, please also let me know. If you have any questions related to these questions, let me know. I have put the link in the chat box also. You can, if you want, you can join through that. So I will try to do that, Ravi Shankar, what you're asking. So I will try to upload the quiz questions, but I think it's going to be a little difficult for me. However, I will see whether I can do it if the time permits. Okay. Thank you so much. Are there any more to join? All right. I think now it's okay, right? So have all of you joined? Are there any more to join? So I will start. Yes, it's software-defined networking. I think all of you got it correct. So yeah, the primary goal of the SDN will be to centralize control the network in a centralized manner. Like SDN is for that. So some of you have answered as manual network configuration. No, there's no manual. I mean, the goal of SDN is to reduce the manual work. So the goal of the SDN is to install softwares in the network components and control the network using a centralized controller. So what we can do there is like try to control the network using a centralized controller where the central controller can automate the maybe the data traffic controlling part using the observed data. So manual work is reduced as much as possible. So the correct answer will be centralized network control. If you have any questions, you can ask. Okay. Correct answer is network function virtualization. I think everybody got it correct. Right. So the purpose of network function virtualization basically in IoT is to uh, improve the scalability. Scalability means like improve the ability to uh, cater like large amounts of data or large amounts of devices. So scalability means you can scale the network more and more. You can increase the scale of the network more and more in a flexible manner. So in IoT networks, we are, as I said before in one of the slides, IoT networks will be networks which are having large amounts of devices in the network. IoT devices will be uh, in large amounts. So if for a certain application, let's say like a some kind of agricultural scenario where we are placing sensors in each of the different points in the agricultural area. So in that case, we are adding a lot of devices to the network. So we are actually increasing the number of network connected devices. So the network function virtualization helps us to cater all those device requests and um, manage the data traffic in a flexible manner. So the correct answer is improved network programmability and automation. So one of you have answered static network configuration. It's actually like uh, so static means like you cannot change network configuration. It's not the case. Actually, we can update the network configuration if we want from a centralized location. The network configuration protocols are static, but the network configuration can be uh, dynamic. So we can control the configuration through the centralized controller. So we also, I mean, the correct answer is improve network programmability and automation, which means that we can program the network functions and we can automate the network functions using software. So uh, that actually is the main concept behind software-defined networking concept. You can automate the network using network programs, and you can control that also using a certain central controller. The correct answer is enhances security through centralized control and monitoring. So the security aspect can be controlled by the SDN controller. The SDN controller has the idea about each of the network devices and the requests made to the network in general. So the request that each of the network devices receive will also be notified to the controller. So because of this, the controller can identify based on the nature of the requests made, whether it's an unauthorized request or it's an authorized request. So the controller can identify unauthorized requests and remove such kind of requests accessing the network. Also, it can control the network devices not to address those kind of requests. By doing so, the controller will be acting as a like a system that will prevent stop uh, the such kind of requests coming into the network. So it will act as a, like a simple firewalling system. And apart from that, once it knows that such kind of unauthorized messages are reached or coming to the network, then it will notify the necessary firewalling services to stop the security attacks happening to the network. So this is about the M2M communication or machine-to-machine communication that we discussed in the last class. Machine-to-machine communication is about communication between machines or two robots or two sensors without the support of humans or without the support of an external network architecture or network infrastructure. So direct communication between two devices is mainly implied by M2M communication. However, M2M communication also can be extended to communications with the internet, which will lead to IoT networks. However, the second answer, which is communication between humans and machines, is wrong. So machine to machine means the communication happens between a machine to another machine. So the correct answer is by enabling real-time monitoring and control of physical processes. So cyber physical systems is something we discussed in the last class, which is a system that is used to monitor and also control the physical processes that are done at the edge of the network in the cyber physical system. It's also like IoT, but in IoT, most of the time monitoring tasks are done, updating data can be done. However, controlling of the process at the end will not be done in the IoT. Controlling part or like controlling like complex physical processes will be done in the cyber physical systems. So that is the difference between IoT and cyber physical systems in general. Correct answer is encryption, which is the technology which is used to secure data. So artificial intelligence, augmented reality, those things are actually technologies that can be used for enabling some sort of security. I mean, artificial intelligence, of course, can be used for some kind of secure communication using data and all, but encryption is the direct, clear answer here, which is the technology that is used for securing data in the data that we are transmitting, right? So encryption is the correct answer to this question. The correct answer is by enabling efficient network traffic and management and resource utilization. So M2M and CPS can, contribute to um, a smart city concept, and it can do, efficient network management and also resource utilization. So, first one is a wrong answer because it does not discourage connectivity between devices. So, the main concept in M2M and CPS is that you do connectivity or connections between devices. So, you encourage that. So, this first one is wrong. So, with that, I think this is ending. I will upload the results into the LMS. So, thank you for participating in the quiz. Right. I will try to upload the questions if possible, but I cannot ensure that. Maybe you can review all these questions that we discussed and maybe write it on a piece of paper and keep it uh, when you're preparing for the end exam, maybe.